there's a new time standard for the moon. Rust versus C++ is boring. The real third option is CHERI. Your cloud RAM might become a clever algorithmic illusion. NPM isn't ready for what's about to hit them. Imagine the best compilers end up being non-deterministic. Let's talk about what 2026 is going to look like. Now, RAM prices are getting out of control, but you're probably already aware of that if you've kind of been around trying to buy anything in the last year. But what you might not be aware of is that the actual definition that we have for RAM is about to get really complicated. Now, behind the scenes, we've had all of this quiet work in hardware, in the Linux kernel, with orchestrators, trying to change the way we allocate memory. For decades, RAM has been kind of shackled. It's not really so bad as a consumer, but it kind of creates this really irritating problem for hyperscalers. If you're trying to buy a new server, you have this fixed ratio of memory to CPU. So if you want to have a lot of memory and very little CPU usage, sorry, too bad, you're gonna have a lot of really idle cores. That waste starts to add up really fast, and it's not really possible to kind of mix and match. But imagine you started treating memory more like a network fabric. So you have this big shared pool of memory that any machine can request exact amounts from. That is called Compute Express Link, or CXL for short. You've probably heard of SAS, or software as a service, but this one is more like MAS, or memory as a service. And with everything in computer science, there is going to be some trade-off. It's not going to be as fast as DRAM located really close to the CPU, but it's not incredibly slow, which is a good thing. It is different enough, however, to where the operating system does have to treat it a little bit differently. The OS needs to be kind of smart about what stuff goes where, so the hot data needs to be nearby, and then the cold data needs to be in the slower, bigger pool far away. And this is where it gets kind of funny, because there's this old computer science saying that says, "Those who do not know Unix are doomed to reinvent it." Poorly. Basically, we figured out the concept of memory tiering literally decades ago, but the Linux kernel is only just starting to catch up to all of this. In 2026, however, we're expecting this kind of perfect storm where the hardware standard is finally mature enough and the Linux kernel is finally getting better about page placement across memory tiers, and even orchestrators like Kubernetes allow you to schedule workloads based off of the kind of memory that you need. There's a lot more about this topic that I'll just never be able to cover in a single YouTube video, but if you're really interested in memory tiering, and it is a very interesting topic, feel free to follow me on X/Twitter or Blue Sky, where I have a really large series on memory tiering. Basically, to kind of summarize, the entire concept of all RAM is equal is dying, and that's not because it's wrong, it's just because it's too expensive. So my official prediction is that 65% odds that by the end of 2026, at least one major cloud provider will provide a compute offering with a tiered or burstable memory class where you explicitly pay less for CXL-backed memory. And I'm only medium confident on this because dealing with memory tiers gets a little bit complicated for customers, but I'm very confident that CXL is going to be used a lot in hyperscalers. Really, the only question here is, are they going to reveal this to users or not? All right, next prediction. One of the most difficult computer science problems is time and space. And no, I'm not saying time and space, I'm saying time in space. For as long as we've been in space, NASA and other space agencies have been using Earth as the master clock for performing missions, but that's actually not how time works. 2026 is probably the year a Coordinated Lunar Time standard is actually finalized. And it's really complicated, so let me just explain a little bit more. Because of general relativity, moon time actually runs at a different speed than Earth time. Technically, that means we need to be dealing with time scales rather than timestamps plus offsets, because the moon runs just a little bit faster than we do on Earth. So Earth runs a little bit slower because we technically sit fit in a deeper gravity well. So the moon runs about 56 microseconds faster than on Earth, which doesn't sound like a huge difference, but it actually makes a really large difference for computers and trying to keep synchronization. Whoa, hi geese. I'm encroaching on your territory. Ah. You have to remember that we created the definition of a second here on Earth. The international standard is based off of cesium clocks, so all of this is from our perspective of time here on Earth. But a second is going to be different here on Earth than it is a second on the moon. This is going to be a really big mess because soon we're going to have really large satellite constellations on the moon, like LunaNet for example, and we're just going to have increasingly large amounts of compute on these. It might kind of sound far-fetched right now, but can you imagine debugging a race condition where the bug is the flow of time itself? You might be wondering how NASA did it in the past with Apollo and subsequent missions. And the answer is that they cheated actually, because they had this kind of concept of smart Earth, dumb moon, where as long as you kept constant communication between Earth and the spacecraft, then every single command from mission control is basically sending the correct timestamp and kind of resetting that drift. Anyway, there's been kind of a lot of pre-work done in this, but nothing has been super officially published and standardized, which is why I give 80% odds for an official implementation strategy being published for a Coordinated Lunar Time as an operational standard. Fun fact that NASA is supposed to have a deadline of December 31st, 2026, but I'd argue there's kind of a non-zero chance of that slipping with like the current presidential campaign and such. All right, next prediction. Wow, that's bones. Oh, I think it's a whale. Oh my gosh, whale bones. You know that whales are so loud that they can like vibrate you to death if you happen to be in the water while they're making their sounds? Pretty scary, huh? Hasn't happened though. But it could. Welcome back. Everybody likes to talk about Rust versus C++, and especially like in terms of memory safety. But I'm about to throw you a curveball here because I'm about to throw you something that could make all of this completely obsolete because all of this is actually fixed by hardware. Now, I argue that the Rust versus C++ argument is getting old, is getting boring because there's other options that nobody is currently talking about. So first, let's talk about the different levels of memory tiering. In modern C++, you can write memory safe code, but a lot of the responsibility is in the hands of the programmer still. You have to follow these good practices, and if you do that, you're going to be memory safe. Rust kind of abstracts this away from the programmer because it puts it in the hands of the compiler instead. You can think of this kind of like a wall. In the C++ version of the wall, it's like it's made out of a shower curtain or something like that. So if you do something stupid, you could trip and just fall completely through the wall because it's really not that protecting. Rust takes this one step above. It's kind of like the wall is made of glass, and you're not just going to trip and fall through the glass wall. It's going to stop you, but you could theoretically take a hammer and break through the glass wall. That would be like turning off all safety features. CHERI is something that's even one step above that. That's like the wall is made out of concrete. So no matter what you do, you can bang against the wall as much as you want. You're never going to be able to fall through it. CHERI uses this kind of idea of like capability-based addressing. Kind of long story short, instead of having your standard 64-bit pointer, you have this 128-bit capability that explicitly defines what memory the CPU is allowed to access when it's using this 128 bits. And kind of the nicest part of this is you don't have to rewrite your code for this. Let's say you have some unsafe C++ code here. All you need to do is recompile it for CHERI, and now the hardware is going to catch any of those bugs for you. Personally, I think most of the efforts right now to take existing code bases that are battle tested and such and rewrite them in modern memory safe languages is just kind of misguided, because if you think about it, Modern operating systems are like 50 million lines of code, and one statistic that people like to talk about is that a regular senior software engineer can produce like 1,000 lines of safety critical bug-free code per year. So that means if you follow this kind of metric and you hired even literally thousands of engineers, this is still a decades-long project. But Lori, what about AI and stuff? Well, I have a few different problems with that, but let's just take it at face value and say you can do this. Well, there's just still so much that it is still an insurmountable problem, which is why I like so much the idea of solving this at the CPU level. And this idea is gaining more traction, which is why I give 40% odds that by the end of 2026, some mass-produced consumer device, think like IoT Hub or something like that, will ship with a CHERI-enabled processor. I really wish it was higher, but you gotta be kind of realistic over here. But there is enough experimentation in the RISC-V and ARM space that there are dev boards already available, and I do like any idea that's not just going to be take this entire code base or all of these code bases and blanket rewrite them into a different language. I think it's good to look at the hardware level solutions for this, and maybe this will inspire some of you to take a look at it. Okay, I got a really fast but terrifying prediction for you guys. So think about major package repositories. Think like NPM, PyPy for different programming languages and such. My prediction is that in 2026, there is a 70% chance that a major developer package repository has to shut down registrations for greater than 24 hours. It's kind of scary to think about, but it's just getting easier and easier to slip in completely unaudited code into these different package repositories, or even like purposefully malicious AI generated code or something like that. And it's really easy to make all of these packages look completely legitimate. You can have like huge readmes, you can have unit tests, you can have different commit histories and stuff, all making this look extremely legitimate. But some of the best, most challenging attacks are supply chain attacks, where you slip in some Trojanized code in part of like the dependency chain or in a package something is relying on. The worst part of this is this problem gets worse and worse as people start vibe coding more and more. Like put yourself in the shoes, you're trying to vibe code something right now, and you're trying to parse this particular file, and you're like, okay, I need a parsing library for this. So you ask your AI model, and it's like, okay, we're gonna use Fast Parser v2. But the problem is Fast Parser v2 actually doesn't exist, at least legitimately. But there's a second part of this that's even scarier. Let's say some malicious actor knows that this is some really commonly hallucinated library, so they decide to make a version of this hallucination that is a malicious version of the library, so it's actually slipping in a backdoor or something that you're willingly installing on your system. And this is such a scary concept. It's called Slopsquatting, which is kind of a funny term I hadn't heard of before, but it's where malicious actors just generate a ton of these different packages in the hopes that somebody will accidentally use them. I'm really thinking the era of this kind of anonymous publication to these large package repositories is just going to start to come to an end, and we're going to have some kind of trusted developer verification to be able to push to these repositories. Otherwise, the problem's just going to keep getting worse and worse over time. Kind of reminds me of the Discord verification. Anybody see that? Where it's like the thumb, and it's got like a little face drawing on it. He's like showing it to the camera for age verification, and Discord's like, oh, we estimate your age to be 13 to 15. Now we're getting on to my personal favorite prediction, and this one's kind of complicated because it kind of gets in the weeds a little bit, but I personally think you should stick around and listen. I'm not biased at all. Anyway, imagine if in 2026 we produce compilers that have a different non-deterministic output at the highest levels of optimization. That means same source code, same compiler flags and such, but when you turn up optimization levels to the max, you might produce a different binary during every single different compilation. And if you're a developer, you're probably thinking like, oh, Lori, man, what are you on? Compiler optimizations are complicated. They're kind of like really big search spaces. So let's say you feed in some source code to GCC or LLVM. It's going to take that and look at the math or something and try to figure out optimal register allocation, for example. But the truth is, these are all actually human-created guesses based off of learned heuristics. Modern CPUs are getting so complex that branch predictors, the reorder buffer, and optimal cache allocations are basically becoming like a near superhuman problem to solve. Really interesting fact, under very specific circumstances, an ML model can do better inline optimizations than a deterministic math algorithm. But pause, because we need to talk here for a second. You might have heard Elon say that by the end of 2026, AI models were going to skip code completely and be writing directly in binary. And like, no, absolutely not. This is an absurd statement. I'm not saying that ML is going to be replacing the compiler at all. I'm saying that under very specific circumstances, in certain heuristics, an ML model can decide good inline optimizations. If you go over and ask an AI model, like, hey, generate me this binary from scratch, what it has to do is it has to pretty much hallucinate millions of opcodes completely correctly. And if it gets just a single byte wrong, or even like a single bit wrong, that program's gonna completely not work. But if you think of ML-guided optimization as a subset of the compilation process, as in like the decision engine, it does start to make sense. Now, Google's already done this for optimizing some binary sizes down, and it actually ended up beating humans by like 7%, which is pretty impressive. And this has been upstreamed back into LLVM back in 2021 already. But my prediction is a little bit different. My prediction is that by the end of the year, 65% odds that LLVM ML Go lists 3+ ML guided heuristics. Right now it's 2. It's inlining for size and reg alloc eviction. If I had to guess, the next one would probably be loop unrolling, since it's like the next logical step. Because if you do loop unrolling improperly, you're just gonna kill the instruction cache with a ton of repeated instructions. But this maps nicely to models. You could use fixed seeds, and there's already quite a few papers talking about how it beats vanilla optimization level 3. I'll link those below. The tricky part is that LLVM is just such a critically important project that the maintainers are super selective about what gets accepted and upstreamed back into LLVM. Kind of the overall sentiment is only use ML solutions when they consistently beat hand-tuned heuristics with safe fallbacks. So those are my predictions for 2026. And if there's one thing that you should take away from this, is that there is a lot of exciting stuff happening still in the field of computer science. And there's a lot of doom and gloom out there, but if you take a little bit of a deeper look, you'll see that there's still a lot of cool stuff happening that nobody seems to be talking about. As always, I will link as many relevant papers as I can in the description of this video. And I'm really curious what you think. Do you disagree with me heavily? Do you have more thoughts on a particular prediction? Feel free to leave a comment below. And don't forget to subscribe if you like this kind of computer science content. As always, thank you so much for watching, and until next time, Lori Wired out. Oh, this goose is approaching me. Hi, Goose. Look at him go. Hello.